Okay, so this is the next part of the AI ML IoT. So now we are going to learn about the how the AI and ML interact. It is said that AI can enhance business productivity by up to 40%. The differences between artificial intelligence and machine learning can be complementary, bringing these two disciplines close together so they can cooperate in numerous fields. AI can be used for a range of tasks that it will complete together with humans. Administrative tasks, decision making, determining the risk levels of certain decisions, etc. AI works as a support for humans, and its main goal is to speed up the process and boost efficiency. As opposed to that, ML processes and organizes data and information, learns how to complete tasks quickly and more intelligently, and predicts problems. Now we have big data, which is increasing its volume in exponential manner. In basic principles, and the extraction of systematization of data into one concise support or report similar to those found in the Google Analytics report in terms of visuals. It is big data that artificial intelligence and machine learning meet and converge again with the most significant consequences. Big data analyzes and digests more data than ever before, which is produced in staggering amounts thanks to more people and devices uploading things on the internet. Using big data, artificial intelligence and machine learning improved services such as computer speech and speech image recognition. Let us try to understand what is big data and its role in using AI, ML, and IoT. So, first, what is big data? Big data is a term that describes large, hard to manage volumes of data, both structured and unstructured, that include businesses on a day-to-day basis. But it's not just type of or amount of data that's important, it's what organizations do with the data that matters. Big data can be analyzed for insights that improve decisions and give confidence for making strategy business moves. Big data refers to data that is too large, increasing very fast, and complex that it's difficult to or impossible to process using traditional methods. The act of accessing and storing large amounts of data or information for analytics has been around for a long time. But the concept of big data gained momentum in the early 2000s when industry analyst Doug Lanning and articulated the new mainstream definition of big data as the three V's, that is, volume. Organizations collect data from a variety of sources, including transactions, smart devices or IoT devices, industrial equipment, videos, images, audios, social media, and more. In the past, storing all that data would have been too costly, but cheaper storage using data lakes, Hadoop, and the cloud have erased the burden. Velocity. With the growth of the Internet of Things, the data is streamed into businesses but on an unprecedented speed and must be handled in a timely manner. RFID tags, sensors, and smart meters are driving the need of deal with these for torrents of data in real time. Variety. Data comes in all types of formats, from structured or numeric data in traditional databases to unstructured data, that is, in documents, emails, videos, audios, stock tickers, data, and financial transactions. Later, two more types of V's have been added, that is, variability and veracity. Let us try to understand these two also. Velocity is the increasing velocities of data. Data inflows are unpredictable, changing often and varying greatly. It's challenging, but businesses need to know when something is trending in social media and how to manage daily, seasonal, and event triggered peak data loads. Veracity refers to the quality of data because data comes from so many different sources. It's difficult to link, match, cleanse, and transform data across systems. Businesses need to connect and correlate relationships, hierarchies, and multiple data linkages. Otherwise, their data can quickly spiral out of control. Why is big data important? The importance of big data doesn't simply revolve around how much data you have. The value lies in how you use it. By taking data from many sources and analyzing it, you can find answers to that. Streamline resource management, improve operational efficiencies, optimize product development, drive new revenue and growth opportunities, and enable smart decision making. When you combine big data with high performance analytics, you can accomplish business related tasks such as determining root causes of failures, issues, and defects in real time, spotting anomalies faster and more accurately than the human eye, improving patient outcome by rapidly converting medical image data into insights, recalculating entire risk portfolios in minutes, sharpening deep learning models' ability to accurately classify and react to changing variables, detecting fraudulent behavior before it affects your organization. How big data works. Before businesses can put big data to work for them, they should consider how it flows among a multiple of locations, sources, systems, system owners, and users. There are five key steps to taking charge of the big data fabric that includes traditional structured data along with the unstructured and semi-structured data. Set a big data strategy. Identify big data sources. Access, manage, and store the data. Analyze the data. Make intelligent data driven decisions. Set a big data strategy. At a high level, big data strategy is a plan designed to help you oversee and improve the way you acquire, store, manage, store, and use data within and outside of your organization. A big data strategy sets the stage for businesses' success amid the abundance of data. When developing a strategy, it's important to consider existing and future businesses and technology goals and initiatives. This calls for treating big data like any other valuable business asset rather than just a byproduct of applications. Identify big data sources. Streaming data comes from the Internet of Things and other connected devices that flow into IT systems from wearable, smart cards, medical devices, industrial equipment, and more. You can analyze this big data as it arrives, deciding which data to keep or not to keep, and which needs further analysis. Social media data stems from interactions on Facebook, YouTube, Instagram, etc. This includes vast amounts of big data in the form of images, videos, voice, text, and sound, etc. Useful for marketing, sales, and support functions. And this data comes or often in an unstructured or semi-structured form, so it possesses unique challenge for consumption and analysis. Publicly available data comes from massive amounts of open data sources like US government's data.gov, with CIA, World Facebook, or the European Union Home Open Data Portal. Other big data may come from data lakes, cloud data sources, suppliers, and customers. Access, manage, and store big data. Modern computing systems provide the speed, power, and flexibility needed to quickly access massive amounts of types of big data. Along with reliable access, companies also need methods for integrating the data, building data pipelines, building data quality, providing data governance and storage, and preparing the data for analysis. Some big data may be stored on site in a traditional data warehouse, but there are also flexible, low cost options for storing and handling big data via cloud solutions. Lakes, data pipelines, and Hadoop analyze the data. With high performance technologies like grid computing or in memory analytics, organizations can choose to use all their big data for analysis. Another approach is to determine upfront which data is relevant before analyzing it. Either way, big data analytics is how companies gain value and insights from data. Increasingly, big data feeds today's advanced analytics endeavors such as artificial intelligence and machine learning. Make intelligent data driven decisions. Well managed, trusted data leads to trusted analytics and trusted decisions. To stay competitive, businesses need to seize the full value of big data and operate in a data driven way, making decisions based on the evidence presented by big data rather than gut instinct. The benefits of being data driven are clear. Data driven organizations perform better, are operationally more predictable, and are more profitable. Thank you.